Hi, third grade. My name is Victoria, and I work for a place called the Steelworks Museum. Have you ever heard of that place before? It's called the Steelworks Museum. So that's right. We teach people here at the museum about steel and the people who made the steel, things that could be made out of steel, how it's made, all kinds of different things about steel. Here in Pueblo, we have a very special place called a steel mill. And a mill is kind of like a factory where steel is made and things out of steel are made. One of the neat things about Pueblo's steel mill is that it's been around for a really, really long time. It's almost 150 years old. Because it's that old, we teach people about the history of our steel mill. We also teach people about science in the steel mill and ways that the steel was made regarding science. So today, we're going to learn a little bit about something called states of matter. Have you ever heard of that before? Well, I'm going to teach you a little bit about states of matter and how it's used in the steel industry. So I'm going to share my screen here. And there we go. All right. So states of matter. What is matter first? Well, matter is anything in the universe that takes up space. So people take up space. We're considered matter. The water in your bathtub is called a different state of matter. It takes up space. The air that we breathe, it takes up space. The trees that are outside, the furniture in your classroom, the desks and the tables and the chairs, all of those take up space. So that's called matter. And there are three main types, or scientists call them states of matter. One of them is called a solid. So does anybody know what a solid is? Well, a solid is something that has its own shape. Inside of that, whatever that solid may be, there are little tiny things called atoms. And those atoms are packed really, really super, super close together. And they don't spread out or move very easily or very much. So for example, I have a metal stick here. It's called a rod, and it doesn't change shape very easily. As you can see, it's made of metal. It's pretty hard. It would take a lot of strength to change this shape, to bend it or to break it. Another solid that I have here is this plastic cup. It doesn't change shape very easily. I could probably step on it and squish it, or I could put it in a fire and burn it, but that would take a lot of effort. So this is still considered a solid. It doesn't change shape very easily. Another solid is this pencil. Again, I could break it, but it would take a lot of effort. I would really have to use a lot of muscles to break this pencil. Another state or form of matter is called a liquid. Do you know what liquids are? Well, liquids also have atoms in them, and they're packed kind of close together, but they don't have any type of structure. Liquids tend to take on the shape of their environment. So what do I mean by that? Well, if you pour a liquid in a glass, it takes the shape of that glass. And if you put a liquid in a swimming pool, it'll take on the shape of the swimming pool. So do you see in this picture, do you see how the glass is kind of square shaped? And then look at this picture of the swimming pool. Do you see how it's a rectangle shape? That's what we mean by liquids take on the shape of their environment. They move around pretty easily. So the third state or type of matter is a gas. Do you know what a gas might be? Well, if we add energy to liquids, they tend to change shape and turn into gases. So as you can see in this picture, this looks like a coffee pot full of water that's put on the stovetop, and it looks like the fire is on the stove. And so the heat or the energy from the fire is kind of messing with the atoms. It's getting them really energized and excited. And they're moving around and they're getting super excited and they're actually changing from a liquid to a gas. So as you can see here, the particles or the atoms become excited and they start moving around faster and faster. When they do that, they tend to move further and further away from each other. Just like you see the smoke in this picture coming out of those smokestacks. It's moving farther and farther away from each other. Gases can expand and fill up any container that you put them in. I'm sure you've all had a helium balloon. The helium is a gas, and the gas can fill up the balloon. It can get bigger and bigger and bigger and bigger. Also, if you hold on to the string of the balloon, it's going to stay pretty close to you. But if you let that string go, the atoms that make up the gas in the balloon, they will tend to float away, getting further and further away from you. In the steel mill, we use solids and liquids and gases to make steel. So what I'm going to do is I'm going to read a story to you, and it's called, "Oh, I Wonder How Steel is Made." And while I'm reading this book, I'm going to show you some pictures that go along with the words in the book. Okay. So, steel is a strong metal. Airplanes, cars, and buildings are made from steel. Steel is a kind of iron. Iron comes from rocks called iron ore, which miners dig from the ground. Trains take the iron ore to factories where it can be made into steel. Giant cranes unload the iron ore from the train. A factory that makes steel is called a steel mill. So this is a picture of Pueblo's steel mill right here on I-25. You may have seen it before. At the mill, workers make coke. Coke is a fuel that will melt the iron. It is made by heating coal in large ovens. The coke and iron ore are mixed together in a large furnace. Then the workers add limestone, a kind of chalky rock. Very hot air is blasted into the bottom of the furnace. This hot air makes the coke burn. Inside the furnace, the temperature rises above 3,000 degrees. The burning coke melts the iron ore. A pool of hot liquid iron forms at the bottom of the furnace. Other parts of the ore melt with the limestone. This mixture is called slag. The slag floats on top of the pool of iron and is drained off. As you can see in this picture, the workers drained off the slag in this pot here, and they drain it and they pour it down the side of the hill in this picture. Then the slag is poured into huge containers that are carried on railroad cars. Some of the slag will be used to make cement. Most of it will be thrown away. If the liquid iron were cooled, it would become solid. Solid iron is hard, but it breaks easily. People used to make tools out of iron. In steelmaking, the liquid iron is not allowed to cool. It goes into a different kind of furnace where it is kept hot. Some steel is made in an electric furnace. Steel can also be made in a furnace that is heated with oxygen. The heat in the furnaces removes a chemical called carbon from the iron. As the carbon is removed from the iron turns into steel. A worker takes a sample of the liquid steel from the furnace. The worker takes the sample to make sure that the steel will be strong. As you can see in this picture, here's the worker, and he has a shield here to protect him from the sparks. And this long stick right here has a spoon on the end, and he would dip it into the furnace to get a little sample and then take the sample to the lab where scientists would examine it. Liquid steel may be poured into a mold to cool. Blocks of molded steel are called ingots. Ingots are used to make steel slabs. First, the ingots must be heated again. Then special machines with rollers flatten the steel into slabs. Liquid steel may also be shaped into bars. These long bars are called blooms. Hot blooms and slabs are cut into pieces with torches. Steel is then rolled into thin sheets or shaped with powerful hammers. Steel can be used to make tools, bicycles, cars, and machines. So now that we know a little bit about how steel is made, let's do an experiment like scientists do. What we're going to do is we're going to take two different liquids and we're going to put them together, and those atoms are going to behave kind of funny. They're going to figure out that they really like each other, and they're going to stick together, and they're going to form a solid. So in order to do this experiment, we need a couple of pieces of equipment. First thing we need are some measuring spoons, just like these. We also need what's called a beaker, and I have one right here. Now, if you're outside of a lab, a scientific lab, you might call this a jar. You also might call it like a baby food jar. But inside of our science lab, we call these beakers. You also need something to stir the liquids together. So we have these stir sticks. And you also need some measuring cups, as you can see here. Our liquids today, we have two of them. One of the liquids is called sodium tetraborate. And you can see it's a liquid. It's taking the shape of the container. The container's kind of long and skinny, a cylinder. And you can also see when I shake it, it moves around pretty easily. Remember, solids don't really move around like this, but liquids do. Another liquid that we're going to use today is called polyvinyl alcohol. And it also moves around pretty easily. Now, polyvinyl alcohol, it comes in different colors, but I'm going to use orange today. And you can see it also is taking the shape of this plastic bottle that it's being housed in. Okay. So I'm going to move you a little bit closer to me here. And out of this here. There we go. I'm going to tilt the camera down so that you can see what I'm doing. Okay. So we have our beaker, our stir stick, measuring spoons, and our measuring cups. So the first thing that we need is we need to take these three things and set them aside. And we're going to look at these measuring cups. You can see they come in different sizes. There's 4 of them here. And we want to find the 1/4 cup, which is this one here. And you'll see 1/4, okay, 1/4. Sometimes it'll say 1 with a slash and a 4. Sometimes the 1 will have a dash and it'll be on top of the 4. But this one has the 1/4. I'm going to get my beaker ready. And I'm going to take my polyvinyl alcohol, lid off. I'm going to pour this into here, just like this. I'm going to pour this very carefully into my beaker. Just like that. We're going to set that aside. Now, with my measuring spoons, you can see that we have 4 of these as well. And we want to find the 1 tablespoon. It's the biggest one. And you can see on here, oops, this one says 1 TBSP. Sometimes it'll say 1 with a capital T, and other times it'll say 1 TBS. But this set says TBSP. So we're going to take our other chemical today. This is our sodium tetraborate. And we're going to fill our 1 tablespoon with this. Very carefully, we're going to pour that in. Still, that's not good. Now, You can see it's both of those are in the jar. We're going to take our stir stick and we're going to put it in here. We're going to mix it up. So what's happening right now? Well, we are adding energy into the two liquids, and they're getting, the atoms that make up those liquids are getting really super excited, and they are grabbing onto anything they can find. One of the things that they're finding is if it's an atom that makes up that sodium tetraborate, it's grabbing onto the polyvinyl alcohol, and they're becoming best friends. They're sticking together. And as you can see, our liquid is not nearly as easy to move around as it was before. It's turning into more of a solid. If I was to do this a few minutes ago, all of the liquid would just run right off of my stick. But this has become more of a solid. So one of the characteristics we found of a solid we talked about earlier is that they do not take the shape of their environment. That's what liquids do, right? So if I have this clean glass here, this cup here, and I take my newly made solid, I pour it from this beaker into this cup. Do you think it's going to take the shape of this cup? What do you think? Let's try it and see. Let me move the camera down again. Are you ready? Okay. So we're going to take this and we're going to pour it into this cup. Well, it kind of took the shape, but then again, it kind of made its own shape too. Now, this particular type of solid is a new word. You haven't learned it yet. It's called a colloid. And that means it's a squishy type of solid. You can see here, if I put my finger in it, I can actually move it around. And as you can see, it's only taking up about half of that cup. If I was to leave this out in the air overnight, the air molecules would get in here and they would dry out this colloid. And it would actually make it extremely hard, just like some of the other things that we talked about. Bicycles are hard. That metal stick that I showed you earlier is hard, and so on. So solids are hard. Liquids take the shape of their environment, and gases move easily throughout their environment and can expand into the air. So thank you for learning with me today about solids, liquids, and gases. And I hope to see you at the museum again very soon.